afternoon. This is Dr. P. Venkat Raman, working for the Marri Laxman Reddy Institute of Technology and Management, Dundigal. I am working as the Professor of Mathematics in H&S department. So this is my first lecture. In this lecture, I am going to talk about the numerical methods and complex variables. In this subject, the syllabus is divided into 5 units. In first unit, we talk about the numerical methods. So unit 1, it is related to numerical methods. So the important chapters in unit 1 are, first one, numerical solution of the equation f of x is equal to 0. And second chapter is numerical solution of system of linear equations. In the system of linear equations, mainly we talk about the number of equations is equal to number of unknowns. And third chapter, that is the last chapter, is interpolation. So firstly, we talk about the numerical solutions of the given equation f of x is equal to 0. In this, mainly we talk about the 4 numerical methods to find a real root of the given equation. They are, first one, bisection method, second one is Regla-Falsy method, third one is Noether-Raphson method, and fourth one is iteration method. So before talking about those 4 methods, we should know some important basic definitions and terms. Firstly, we know them one by one. First one is algebraic equations. What are the algebraic equations? Suppose in the given equation f of x is equal to 0. In the given equation f of x is equal to 0, if f of x is a polynomial, for example, f of x is equal to a0 plus a1x plus a2 x square plus so and so plus an x power n. So it is a polynomial in x, and here it is a nth degree polynomial, and here a0, a1, a2, so on, so n are the coefficients or constants. So if the given equation is in this form, polynomial form, then it is called the algebraic equation. For example, you see this example, x plus 2 equals 0. Now it is a equation because it having equal symbol, therefore it is equation, and it is a polynomial, linear polynomial. Here degree of x is 1, therefore it is a first degree polynomial, therefore it is an algebraic equation. Similarly, second example, x square plus 2x minus 4 equals 0. Now this is also equation, but here f of x is a polynomial, second degree polynomial, quadratic equation. It is also one example for the algebraic equation. Third one, x cube minus 2x square plus 4x plus 5 equals 0. Now in this third example also, f of x is a polynomial, cubic degree polynomial, therefore it is an algebraic equation. And last one, x power 4, 2x power 4 minus 3x cube plus 2x square x plus 5 equals 0. Now in this example also, f of x, this one is a polynomial, 4th degree polynomial. So like that, this is also one example for the algebraic equation, and so on. Now next one, transcendental equations. What is the transcendental equations? Transcendental equations means, suppose the given function f of x is equal to 0. Let this is the given equation. In this equation, if f of x is not a polynomial and it having some special function, special functions like exponential function, trigonometric functions, logarithmic functions, etc. If that f of x having those special functions and f of x is not polynomial, then that equation is known as the transcendental equations. For example, you see this example, x e power x equals 0. Here f of x is not a polynomial and this f of x having exponential function. So therefore, it is one example for the transcendental equation. Similarly, we see another example, x log x equal sin x. Now you see this equation, it is an equation no doubt, but it is f of x is not polynomial and this equation involving special functions like logarithmic and trigonometry. Therefore, it is also a transcendental equation. So like that, from this part, I can conclude that equations are classified into two categories. One is algebraic equations and the second one is transcendental equation. Okay. So in the given equation f of x is equal to 0, if f of x is a polynomial, then it is an algebraic equation. In the given equation, f of x is equal to 0 if f of x is not polynomial and having or involving special functions like logarithmic, exponential, trigonometric, etc. Those equations are called the transcendental equations. Next, we move to the next one. Third important definition. Roots of the equation f of x is equal to 0. So this roots of the equation f of x is equal to 0 is, we can define the root in two ways. First one is algebraic definition. What is the algebraic definition? This already you know in 10th class, already you studied. Suppose f of x is equal to 0 be the given equation. If alpha is any number, if this alpha satisfies this equation, that is f of alpha equals 0, then this number is called the root of the given equation f of x is equal to 0. Here alpha may be real number or complex number. Real number or complex number. So second one is geometric definition, because we use this definition in our four methods. So this is very important geometric definition. Suppose the f of x is equal to 0 be the given equation. Let this is y-axis and let this is x-axis, xy plane, and let this is the origin O. Suppose this is the graph of the function f of x graph. Suppose here at a function value is f of a and it is negative, and at b the function value is f of b, it is positive. And you see here this graph of the function crossing x-axis at alpha. So this alpha is defined as the root of the equation f of x equal 0. And see this graph. Here what happened? Here f of x graph. Suppose this is the graph of the f of x. Here what is this intersection point? Alpha 1. What is this intersection point? Alpha 2. What is this intersection point? Alpha 3. Therefore, alpha 1, alpha 2, alpha 3 are the roots of the equation f of x equal 0. So in the geometric definition, the intersection points of the graph of f of x with the x-axis is defined as the root of the given equation. Okay, this is the geometric definition of the roots. Next, intermediate mean value theorem. Because the four methods, what I told just now, those four methods depends upon this theorem only. So this is one of the important theorems from real analysis. And in this theorem, we use this theorem in numerical methods. What is the intermediate mean value theorem? Suppose the given equation is f of x is equal to 0. Let this is y-axis, let this is x-axis. And intersection point is origin. Suppose this is the graph of the f of x. And you choose any two numbers a and b such that f of a having f of a negative and f of b positive. So here choose any two numbers a, b such that f of a and f of b are of opposite sign. Opposite sign. For example, you see f of a negative and f of b is positive. Opposite sign. Then there exists at least one root between a and b. So you see here between a, b, this is crossing at alpha. So therefore, x is equal to alpha is the root of the given equation as per the definition of the geometric definition. So therefore, this is the theorem, and based on this theorem only, we talk about the numerical methods to find a real root of the given equation. So what is the theorem? Again, I will recapitulate. So let f of x be f of x equal 0 be the given equation. Choose any two numbers a, b such that f of a and f of b are of opposite sign. Then there exists at least one root between a and b. So that is the theorem statement. Next, we move to the important methods in Unit 1 in first chapter. Methods to find a real root of the equation f of x is equal to 0. So in this we talk about the four methods. Many methods are there. Some methods designed for complex roots, some are designed for real root. But as per our syllabus, we talk about the four numerical methods to find a real root of the given equation. So first one is bisection method. This method is also known as Bolzano method. Second method is regular falsi method. This is also known as false position method. Newton-Raphson method, third one. This is very, very important and very powerful method comparatively with the other methods. And fourth one is iteration method. So we discuss one by one. Continue this lecture in the second period. Thank you.